just like with numbers, you can square variables in algebra. For example, you can do 3 squared, 3 times 3 is 9. You can do exactly the same with variables. You can write something like x squared. X can be anything, it's just a number, so it could be something like 4 squared, 4 times 4, which is 16. Okay. You can also, just like before, add and multiply these things. For example, you could do x squared plus y squared. Okay, you could write something like that. X could be 2, y could be 3, for example. So that's 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9, so that would be 13. If you have to do x squared plus y squared, that's as simple as it gets. You can't write it any differently or simpler than that. But like before, if you have x squared times y squared, you don't have to write the times sign. That's just x squared y squared. That means exactly the same thing. X squared times y squared is just x squared y squared. Okay. Now, what if we have something like this? Minus 3 squared. Okay? It's very important you know exactly what that means. Because does that mean minus 3, the whole thing, squared? Does it mean minus 3 times a minus 3? Or does it mean do 3 squared and then put a minus in front of it? It's a bit ambiguous, right? Well, it's the latter. That means you do the squaring of this big number first and then you apply the minus. So that means it's minus, I'm going to use brackets here to show you do the thing in brackets first. It's minus 3 squared. Okay? Which is 3 times 3 is 9. So it's minus 9. Now we don't need the brackets anymore, which is just minus 9. Okay? That is correct. That's what that means. It doesn't mean minus 3 times minus 3. That's very important. Because minus 3 times minus 3 would be a minus times a minus is a plus. That would be plus 9, which is different. Okay? So don't get the two mixed up. Right. So that means we can write something like minus x squared. Okay? Or minus y squared or minus q squared. Or we can have minus 4p squared, something like that. Okay? This means, just like that, it's x times x and then minus whatever that is. Okay, good. Right. What if we have something like, let's have x, y squared. Okay? That just means x times y squared. Well, it's a similar thing to this. The squared only applies to the y. Okay? That doesn't mean xy times xy. There are no sort of invisible brackets around the xy. Okay? The squared is only applied to the y. Very important. So let's put in some numbers to illustrate this. Let's say x is 3 and y is 2. Okay? Then this becomes x is 3, so it's 3 times y squared. Only the y is squared. Y is 2, so it's 3 times 2 squared. Okay, is that clear? The squared only applies to the y. So that's 3 times 2 squared is 4, so it's 12. Good. Okay. So that is different. Let's say the x and the y were in brackets. Okay? let's say we had xy brackets, the whole thing squared, right? Let's work that out and you'll see it won't be 12 to prove that these two things are different. If x is 3 and y is 2, that becomes x is 3 times y, which is 2, 3 times 2, all squared, okay? Which is 3 times 2 is 6, all squared. 6 times 6 is 36. See, I told you 12 and 36 are not the same, which shows that xy squared is not the same as xy all squared. So you can put in brackets in various places if it helps you understand it, the way I put in brackets here to show that you do the 3 squared first and then apply the minus. And something with brackets here and something without brackets here, they're different things. 12 and 36 are different. Okay, moving on. You often hear the phrase combine like terms in algebra. What does that mean? Well, if you have something like this, let's say you have 4x plus 3y minus 2x plus 4y, okay? That's what you'd describe as an algebraic expression. There's no equal sign, so it's not an equation, it's just an expression, stands by itself. You might be asked to combine like terms. What that means is you've got to simplify it and combine the terms using all your algebra skills you've already talked about to make it smaller and simpler. So, let's look at this first term, 4x. The only other terms, these are all terms, okay? The only other terms that you can combine that one with is other terms that has just an x, okay? No x squareds, you can't combine them. There aren't any in this anyway, but we'll do an example of that in a minute. Only x's. So the only term you can combine this one with is this one, because that's got an x in it. And these don't, they're y terms, so you can't combine them with this. So we're going to combine this one and this one. So this whole expression is equal to 4x minus 2x. So 4 of something minus 2 of something is 2 of something. So it's 2x. 4x minus 2x is 2x. Okay? And we can also combine these two, because they're both y terms. They're the same type of term, so we can combine them. Plus 3 plus 4 is plus 7. You've got 3 of something plus 4 of something. It's like 3 apples plus 4 apples is 7 apples. So it's plus 7y. Okay? And that's called simplifying or combining like terms. Let's do a slightly more complicated example, but it's exactly the same thing, just using squared terms. So let's say, what if we had 3x squared, okay, plus 2y squared, all right, plus 2x squared plus 4x. Okay? Let's simplify that expression by combining like terms. So that becomes... Right, look at this term here. Which of these terms can we combine this one with? Well, this is an x squared term. It's not an x term like that one, okay? You can't combine an x squared term with an x term. We can't do 3x squared plus 4x. That's as simple as it gets. Just those two terms that together, you can't do anything with. The only term you can combine an x squared term with is other x squared terms. So it's going to be this one, and this is the only other x squared term. So we're going to combine those two. So 3x squared plus 2x squared is 5x squared. Okay? So we've dealt with those two. Let's do this one. The only other terms we can combine this one with is other y squared terms. But there are no y squared terms other than that one, so we leave that one alone. And that's just left as 2y squared. Okay, so we've done that one, and that one. It's just this one left. Same thing. That's the only term of x. That's an x squared, that's a y squared, that's an x squared. So we can't do anything with that. We just leave it as it is. Okay? So that is as simple as it gets. We've combined all like terms. There's only one combination necessary, as it turns out. And you can't write it any more simple than that. Okay? So, that's your introduction to algebra. Don't be intimidated by algebra. It's not as difficult as it looks. Just remember, if you ever get stuck, all these funny x's and y's and x squareds and a squareds and p squareds flying around, they're just numbers. All these letters, these variables, they're just numbers. So if you get confused, just think of it as a number. If you're handed something like, I don't know, x cubed, okay, and you're not sure what that is, just imagine it as a number. Imagine x is 2, okay? 2 cubed. Okay, I'm used to that. It's 2 times 2 times 2. Okay, so 2 cubed is 2 times 2 times 2. Therefore, x cubed is just x times x times x. Okay? These variables, they're just numbers. And I'll finish by saying it's very important you get good at algebra, because it's like the language of mathematics in a sense. It comes into every single area of mathematics that you'll be doing in the future. It's the bread and butter. So it's essential skills. You can't do or get other questions right in the future unless you can do algebra, because it forms a part of all the questions and areas of maths that you'll be covering. So make sure your algebra skills are very good.